We left off last time with the motor and 2-speed gearbox installed in the lathe, and it's time to get some power to it. The plan is to install a VFD on the right side of the lathe underneath it. I fabricated a bracket to hold everything and started wiring. The drive is a 220 volt single phase supply going to a VFD, and I've got a transformer for low voltage to go to the lathe's original on-off, which triggers a contactor that then supplies the VFD. This all gets installed in the base of the lathe from the right hand side, and I'm using liquid tight conduit to run cables from the electrical inbox at the back of the lathe and also to the motor. Throughout, I've wanted to use the lathe's original controls. This is the drum switch in the headstock with neutral, forward, and reverse. I needed to make a jumper to make the drum switch work with the VFD controls, so I grabbed a piece of small copper tubing, slid it, and formed it to suit. And the drum switch works really well with that arrangement. Most of the work in using the original controls is figuring out how to use the speed controller. The original speed controls consist of a lever to change the 2-speed gearbox, and then another shaft inside of that lever shaft that is rotated to have a variable speed control. I 3D printed a Mark I version using the original sprocket and chain, which worked okay, but it needed to be more compact, and I also wanted to have stops in to protect the pot. So the rest of this video is about the Mark II version, which is working quite well. Alrighty, here is a fresh batch of 3D printed parts. Ooh, this is using a Bamboo XC1, X1C, whatever, with the filament server. It lets me swap between the color I'm printing in and the support interface material. If you're new to 3D printing, you often have to print supports. So this stuff here is supports. There's a hole going through there, and you have to have support so that when you get to these upper layers here, you're going over a hole. There's something for the plastic to sit on. And it can be a real nightmare when you can only have one type of filament, because the parent material and the support stick to each other. Whereas if you use a multi-filament machine, you have the option of using a filament that sort of sticks to the parent material but doesn't really stick to the parent material. So here, if you can see it, but there's a white layer on top of the blue-gray layer. This stuff's more expensive, so you print the bulk of the support in the parent material, but then on the interface layer between the two, you have this special material. So that's just a huge advantage of the multi-filament style of machine. And I find this very, very thin artist palette knife is just ideal for pulling stuff off. So we'll just give this kind of a quick clean. Yeah, this palette knife, it is 6 thou, so it's just really good at getting underneath and picking off the little bits of material. So just to give you an idea how easy this is, hack through this there. You can just sort of pull this stuff off. You see it comes out so nicely. You get a bit of residue left in there, but it's much nicer than the nightmare you can get with the support printed in the parent material. So the project here is to create a potentiometer speed control for a VFD that uses the lathe's original controls. And look at how nicely that comes out. That would just be a nightmare without the separate material. The original controls on the lathe was this lever here, was the gear shift from the high and low. It actuates via this block here that goes on the end, and that links to the gearbox that goes on the shaft there with the key. And then this shaft here was the speed control. This version is round 2. The original attempt is shown in the photos that used the chain and sprocket that came with the lathe. And it worked well enough, except for 2 things. There wasn't enough clearance to the lathe belt, and second of all, no stops limiting the angular movement of the knob, so it would be very easy to put too much torque into the knob that would potentially damage the potentiometer. The new version solves that by putting the mechanism up above the shaft itself and having keyed stops in both directions to limit the angular movement of the shaft so that the potentiometer can't be damaged. I just recently put this together. It's kind of a little mini hot press soldering iron to press these inserts in, and it's spring loaded. And it's not absolutely necessary. I mean, I've did these inserts for years. And what I'm going to do is I'm going to use this to press in this plastic insert here, a 3mm thread, and turn this down to about 260. This piece is slightly angled. Even with this rig, you kind of need, and I've got little tips on this that fit the different. You can get all this off of Amazon. So just let that warm up, and I press that in. And it keeps those inserts reasonably well aligned, so then I can come along once everything's all kind of put together. So this goes on like so, and that little lug goes into the stop there. That all looks good. It just limits. I've got 2 of them, one for each direction. Onto the pot. Looks good. Right, except that's going to go, these have to bend dramatically forward. That goes like so, and then that goes like so. So this is going to hopefully these cheap screw assortments are just so easy to get off of Amazon, and I know they're lousy quality, but you're not using any high torques with assembling plastic stuff. So that is going to have to kind of be curved over like so. And that goes on like perfectly. TPU is sort of a, I don't know if I can, yeah, you can sort of see the flex there. It's a flexible plastic that you print. And inside, I've got a profiles in it that matches these. I just, you know, I measured the diameter, I counted them up, and I put a pattern of V grooves around it that actually work quite well. So it's a bit of a snug fit, but it just fits perfectly. And that'll be the coupling between the potentiometer in there, and the other end just goes in that square. Okay, that goes there, which is okay. And I'll wait till I'm out at the lathe before I do all the final clamping on this. And then we have the other stop block, which fits there. And I need a bearing in there. That's the last thing to do. I wish that was a little tighter. I did increase the size. It's a little tighter on the shaft, which is good. So hopefully that all stays put. Yeah, well, looks good so far. The spacers are where they're supposed to be. Got my two stops I'll be able to set. You turn this, and the gears very smoothly turn the pot. Let's go install this. This is the link for the 2-speed gearbox, of course. And this kind of goes like this. Access it to get the cotter pin in the other end. Boy, that looks pretty good. I think I'm going to be happy with that. I've got to get into the bottom to hook up the bottom linkage there, so I need to move the camera. Now to put it into, take it out of back gear, put it into direct drive, I just loosen that, move that over, make sure that it's clicked in place, and tighten the screw there. That's 1200 RPM. It's a dog clutch in the transmission or in the gearbox, so if you drop the speed all of a sudden, sometimes you can hear the dog clutch sort of clunk a bit, like there, but it's not an issue. Yeah, it's a good runner. I'll be happy with that. I've rebuilt, I haven't reconditioned the lathe, but I've redone the gearbox, which is an enormously complicated affair. I've redone the saddle. Everything works. That was feeds, thread cutting, which of course you're not likely to be doing that fast. didn't move this to threads. Okay, this should be thread cutting here. There, that's thread cutting. With thread cutting, the gear train here is active. When it's on feeds, it's not. Now the gears may still rotate, but that's just because of the oil moving inside. So when it's in fed like that, there's no gear connection to the spindle, so you can't get any noise and gear noise coming through. 85 years old, not many lathes would compare with this one. That's about 1600 RPM, but I have to admit it's going to be fun coming out here and playing with the speed controller. That's it. Thanks for watching.